virtual memory management, which we have done priorly. That means with just 2 GB of RAM, it can actually picturize 10 or 16 GB of RAM, just rotating pages. Smart now. Going further, we have the local procedure call facility, which will allow you to make low-level calls for the different processes, inter-process communication or process to hardware communication. All this would eventually communicate with the kernel. Kernel will issue low-level commands to the hardware abstraction layer, and finally from the OS specific to hardware specific command would be converted via the hardware abstraction layer, and finally we will go back to the hardware and work with the hardware itself. So that's it. That is how the Windows 7 is going to work. One of the major component over here would be the kernel. I would like to talk more onto it. Let's go to the kernel side. Okay, let's understand kernel. Kernel basically provides a foundation for the executive, that means for the execution purpose, and subsystem, that means the several small parts available in the operating system. So how things are going to go? Let's understand kernel has 4 major responsibility. Thread scheduling. Let's understand Windows 7. Like other prior versions of Windows 7 is also multitasking. The term multitasking comes with the multi-threading facility. The obvious thread scheduling and managing would be first responsibility of the kernel. Along with this, interrupt and exception handling. If something goes wrong, exception needs to be handled. This is much similar concept to the people familiar with the Java or OOPS. Anything goes wrong, there is an exception, then do what? Then do what would be exception handling, which is again a responsibility of the kernel. Interrupt handling. Certain real-time event which suddenly pops in, real-time events would be generally going through the interrupt handling, and they would be served. Going further, low-level process synchronization. Today we are talking about octa-core, quad-core. Let's understand this core simply means there are, for instance, if we say octa-core, 8 processors with 8 pipelines are available. Now, obvious, these cores would work in synchronization with each other in order to produce the maximum utilization, maximum throughput, and maximum working, and that is given by the low-level processor synchronization. Recovery after the power failure. This is a beautiful feature of Windows 7 which have saved myself and my work so many times. Suddenly you are working and power goes off. Windows 7 has a capability to remember at a regular interval what you were doing so that it can recover and do. This is much similar to you closing down Mozilla Firefox and then starting and again Firefox remembering the fact that what all the pages you visited and asking you whether it should open all the tabs. Imagine the same kind of functionality is given to Windows 7, giving the biggest advantage of remembering what application we opened, and we can start where we left our work before the failure. Kernel is object oriented, making it more clear about how to do rather than what to do. So the concept is simple, objective is fairly simple. What you intend to do is more important than how you are going to operate the overall thing. It has 2 basic sets of objects, dispatcher objects, which will dispatch the work. The basic idea behind this is fairly simple. We can divide threads into 2 parts. The dispatcher and the worker thread. The logic is whatever request you are coming or getting is given to the dispatcher. Dispatcher would decide which would be the best working thread or workman thread. End result, dispatcher will give that work to somebody. Consider in case 1 it is given, maybe for the next it is given to somebody, and so on. The request would be given to a particular thread for the serving purpose. Same way, it has several internal things which include synchronization, which is very important when you are working with multi-processing system. Then you have a control objects. Control objects does sudden calls. That sudden is asynchronous procedures, interrupt, power notification, and so many other things. So this is the entire architecture of Windows 7, which requires 3 things. First is the modes, followed by the diagram, and followed by the mode of the kernel. So that's it. This is your Windows 7. Hope you have understood what you are using. Thank you.